Hey, sir.
Good morning, sir. Sorry, good evening, sir.
Yeah, good evening, sir. I will introduce the speaker.
Yeah, okay.
Okay, sir. Right. Yeah.
Thank you for making it.
Yeah, sure, sir. Welcome always.
Raghavendra, sir.
Yes, sir. Good evening.
Good evening, sir.
Yes.
So there are still some participants who have messaged us that they'll be joining a little bit late.
Okay.
So we will be starting at 6:05, sir.
All right. No issues. We shall wait.
Yeah. Thank you, sir.
Okay.
Thank you.
Yeah. Thanks.
Good evening, everyone. We'll start the session in 2 more minutes. Let us wait for the few more participants to join.
Yeah. Uh, Good evening, one and all. Uh, Raghavendra sir, can we start now? Or else should we
Yes, we
wait?
can commence now. Yeah,
Yeah.
I think we are good to start.
Okay, sir. Thank you. Uh, Good evening, everyone. I am Mr. B. Jagadish, Assistant Professor in the Department of Civil Engineering, CVR College of Engineering. I now take the privilege of inviting you all to the day 5 of 1 week short-term training program on advanced beam techniques for civil engineers, uh, organized by the Department of Civil Engineering under the in association with the CVR Civil Engineering Association student body. Sir, the total participants include students, faculty, and some industry personals who are aspiring engineers in the field of beam. And now, with your permission, I would like to invite Dr. B. Ramanjaneyulu, Assistant Professor in the Department of Civil Engineering, to introduce today's guest speaker, Dr. R. Raghavendra Kumar, sir, who is working as Assistant Professor in Nikmar University, Pune. Dr. Ramu?
Yeah, thank you, sir. Yeah, good evening, everyone. Once again, I warmly welcome all the participants to this day 5 of the SATM training program titled Advanced BAM Techniques for Civil Engineers, organized by the Department of Civil Engineering, CVR College of Engineering, Hyderabad. I am Dr. Abtce Manjanelu, Senior Assistant Professor in the Civil Engineering Department at the CVR College of Engineering, and it gives me great immense pleasure to introduce the today's distinguished speaker. Dr. Raya Raghavendra Kumar is currently serving as Assistant Professor at the School of Construction, Nikmar University, Pune. He holds a PhD degree in Civil Engineering with specialization in Construction Management from BITS Pilani. He has strong academic and research expertise in areas such as building information modeling, infrastructure planning and management, energy efficient buildings, and rainwater harvesting. Dr. Raghavendra has made significant research contribution in a granted patents, several publications in reputed international journals, and presentations at various national and international conferences. He has taught various subjects courses such as Advanced BAM, BAM for Energy Management, Quantity Surveying and Cost Estimation, Construction Project Management, and Safety Management in Construction Projects. He has also had the long-term teaching experience of around more than 7 years. With his rich academic experience and deep understandings of BIM technologies, I am confident that today's session will be highly informative and beneficial for all of us. On behalf of the organizing team, I extend a warm welcome to Dr. Raya Raghavendra Rao Kumar. Sir, we are very honored to have you here. Thank you, sir. Over to you.
Yes, thank you, Dr. B. Ramanjanelu sir, as well as Dr. B. Jagdish, for starting the today's proceedings. So, firstly, I thank the entire organizing team as well as the management of CVR College of Engineering for lending me the opportunity to share my experiences in the domain of BIM, where today I will be focusing on particular topic such as service management as well as infrastructure management. So I think we are good to go because I can see there are close to 56 participants. So let me share my screen first. Are my slides visible? Can anyone
Yeah.
confirm?
Yes, sir.
Yeah, all right, fine then. Okay. So yes, as informed earlier, this is going to be the topic for discussion for today, which is 1 minute. Yeah, so which is BIM for Services and Infrastructure Management. And thank you for very nice introduction about me. So as my current affiliation is with Nikmar University, which is located in Pune. So I deal here with School of Construction. And yeah, so that is with respect to me. Right. So now let's see the current overview of today's presentation. So since today is the fifth day of the short-term training program, I will be just only showing you the brief overview of the concept of building information modeling. So I will be not discussing entirely everything, why, because already which has been covered by multiple speakers earlier. So since today is the second last day, I will just have a recap or a small kind of revision of what is BM about based on the current literature. And then later we will be discussing on two particular aspects. So one is BIM for service management and the other one is BIM for infrastructure. So where we will be discussing on BIM and GIS integration and its relevant workflow and some couple of case studies as well as hands-on with respect to the tools usage in this topic for our interest for today. Right. So now, firstly, obviously, in the current 21st century and in the year 2026, all of us know that BIM is a very trending topic, as well as digital transformation in construction sector is a very how to say this, very well-known topic also, right? And most of us are trying to adopt this particular technology. No doubt, many private industries, AEC sectors has already adapted as well as implementing that to a large scale. I do agree with that. And also simultaneously from the public sector undertaking also, we have to observe that there is this particular need for BIM skills to be enriched for the engineering professionals in the construction sector. So let's see why the particular need is being developed, because we see that multiple organizations such as NBCC, which is National Buildings Construction Corporation, as well as multiple metro rail corporation, name it Hyderabad Metro Rail Corporation, or if not Pune Metro Rail Corporation, Nagpur Metro Rail Corporation, DMRCL, which is Delhi Metro, Bangalore, name all the metro rail corporations in India which have mandated BIM workflows into the execution at the right point of time. And also Ministry of Road Transport and Highways as well as CPWD has also made it a mandate that the projects exceeding 500 crores to be executed with the incorporation of BIM technology. So with this kind of basic background, we try to emphasize on that, particularly where virtual design and construction has got its prominence day by day. It is increasing. and also all the professionals as well as stakeholders, that is engineers, architects, as well as construction managers, are playing a key role to enhance their BIM expertise to make sure that nation's smart city as well as urban development initiatives are rightly incorporated. Fine. So this is the basic kind of comparison which all of us are now familiar with, today being the second last day. So where you can see that on your left side where we have a traditional approach kind of setup, and on the right side we have the BIM approach kind of setup, where on the left side where you can see that all the stakeholders such as project managers, structural engineer, construction manager, and other stakeholders work togetherly on a single motive, but in a very fragmented manner, where the communication or collaboration do not happen in a seamless manner. Whereas coming to the BIM concept, you can see that all of them work together on a real-time project tracking basis, where you can see that a cloud-based platform can be used or integrated, where the multiple stakeholders can be involved and they try to access as well as keep a track of the project and execute the project even from a remote location. So this is the basic theme behind the emergence of BIM approach, which is in comparison with the traditional approach. So just the definition is that obviously most of the textbooks or even the literature says that BIM is basically the construction management process which is adopted across the project lifecycle for the achieving of multiple deliverables. Okay, so now in this particular construction management process, where you can utilize or manage multiple virtual representation for each and every physical as well as functional characteristics, either it can be a building or either it can be a physical asset or either it can be a functional asset, throughout consolidating the multidisciplinary data. So we'll be discussing what this multidisciplinary data is all about in the upcoming stages of our presentation for today. So where we try to incorporate multiple tools, technologies, as well as software. Definitely, BIM is not just usage of one particular tool. Maybe, for example, the very well-known or widely accepted tool is Autodesk Revit, right? It is not just one tool, whereas it is focused only in the aspect of 3D, which is your geometric modeling. Whereas it is a process where you incorporate multiple tools, technologies, and software throughout the project lifecycle. So that is the basic core point which everyone needs to comprehend when understanding about the BIM process, right? So it is basically a platform to share knowledge for information throughout the project lifecycle. Fine. So this is the basic background which all of us are aware of. So moving ahead without discussing or emphasizing more on this, let's proceed further. So I believe that this topic has been covered earlier, where we can see that the multiple dimensions of BIM, as well as how the dimensions have progressed right from 3D till 10D. So currently we prefer to say that as 3D to ND, where you can coin the word or letter N as numerous dimensions, where because at each and every dimension you are trying to acquire multiple datas in its relevance for the project deliverable, right? So where you have 3D, that is geometric modeling, where we have the multidisciplinary data getting into the picture of your architecture discipline, structure discipline, as well as MEP discipline. Then next 4D is your scheduling schedule management, 5D is the cost management, 6D is the sustainability. Later, next we have 7D as the facility management, 8D as the safety management, and then 9D we have as the lean construction, and also 10D we have it as the construction industrialization, which is the current phase of BIM progression which is happening in the area of digital twins, right? So this is about the multiple dimensions in BIM. So now going to the main crux of today's topic is with respect to the service management. So let's see what the service management is all about. So before that, these are the multiple tools and softwares which you can adopt in the BIM environment with respect to the multiple phases of a project. So in the planning stage, you can use multiple projects such as MS project or maybe kind of Outlook kind of thing, and etc. Whereas coming to the authoring stage, that is where you are developing one particular model. So where you can focus on the aspects such as SketchUp, Revit, Vectorworks, Tekla structures, Graphisoft, ArchiCAD, and etc. And then next, moving ahead in the analysis stage where you can focus on Navis work, BIM Collab, Solibri, BIM 360, which is right now said as ACC, which is Autodesk Construction Cloud. And then going to the usage stage, that is post the construction, where you can focus on multiple tools such as Synchro as well as Trimble Connect and also Ecodemus, etc. So which will help in the entire project lifecycle. So let's see what this BIM for service management is all about. So service management is basically about the emphasis on MEP, which is basically as very well-known term known as mechanical, electrical, and plumbing technicalities. So let's see what MEP comprises of in the aspect of a components. So where you will use the process of data-rich 3D models to design, install, as well as maintain, as well as manage your entire building internal system. So let's see what are the components. So primary components here we have are the first one, which is said to be HVAC system, which is heating, ventilation, as well as air conditioning system. Later we have electrical and lighting system. After that we have plumbing and firefighting equipment system. Next we have the other one, which is ELV, known to be extra low voltage system, and the other one we have is BMS, which is focused on building management system. Right. So here you can see one particular snapshot, or if not a kind of captured image where MEP works has been done for a particular kind of industrial building, how the coordination can be done like this. Now, just to have some responses from the audience. Now, can I know what are these red color pipes? So let's keep it slightly academic, interactive. So can I get some responses from the audience?
Maybe
So here
firefighting related.
Yes, exactly. Very good answer. That is the firefighting equipment element modeling done. Then next, moving ahead, what is this kind of pinkish color uh, type of modeled element? If I want, I can zoom in a little bit. Yeah, this pinkish color. Ash and pink colored borders. Any responses?
Sanitary fixture.
Come again, you are not audible.
Sanitary.
Sanitary fittings. Actually, these are HVAC systems, right? So they are the ducts provided. And the next, any reflection on green color pipelines? I think now your answer will suit into this. The person who has just now replied. Can you say now? Any response? What are these green color pipelines?
Water pipes.
Yes, madam, it is definitely water pipe. But here, as you know that in buildings, there are multiple types of water pipes. So it can be a hot water pipeline, or either it can be a cold water pipeline, or either it can be a gray water, that is the drainage pipeline. So generally in the Revit part, we try to prefer and create the green color pipelines as the sanitary pipelines or the gray water pipelines, right? So that is how these different colors of gradations are given when you work on MEP models on any tools. So basically that is how you can represent it in a BIM environment, right? So thank you. We had very good responses from the participants. So let's proceed further. So now let's see the different components. Let's have a brief or in-depth understanding. So just now, as we see that mechanical system, we have HVAC system as well as firefighting equipment, and also elevators as well as escalators, maybe in the case of any residential building or maybe in a commercial building. Coming to electrical services, we will focus on the aspects such as power distribution lines, lighting systems, as well as communication networks. Either it can be with respect to such as CCTV, relevant ducting work, or if not, any kind of communication network such as your kind of data cable networks, right, where we try to provide our multiple landline, or if not any particular Wi-Fi routers and all those particular kind of electrical ductwork which can be performed. So here you can see some representations in the realistic appearance. So this is with respect to the mechanical as well as the electrical services. And then moving ahead, the next one we have is plumbing services, where we have the focus on the aspects such as water supply and distribution, drainage systems, and also sanitation and waste management. So when we say that as plumbing services, let's not just limit our thinking only with the aspect of the superstructure for the building purpose itself, whereas it is beside the superstructure, we have the substructure as well, where we say that as utility layouts as well, right? The underground utility layouts as well, where we focus on the aspect of multiple underground pipelines as well. Okay, so let's see the detailed components of the MEP system. So HVAC system, what does it comprise of? So basically it comprises of 4 categories. So the 4 categories we have are, the first one is plant equipment. So here in the plant equipment, we focus on modeling the multiple aspects such as chillers, which is focused for the cooling purpose, boilers, and as well as the next one we have is AHU, which is air handling units. Then next, coming to the distribution, right? So where we have the aspects such as galvanized or flexible steel pipes, where that transport the treated air through the building. And then the next one we have as terminal units, which are said to be VAV, known as variable air volumes, which can be with respect to the boxes, diffusers, grills, where the air enters into the room. And then next, piping connections we have, such as chilled water, hot water pipes that carry the thermal energy between the plant room as well as the AHU, which is your air handling unit. So this is one typical representation about how you can create a HVAC system for any desired building model, right? So let's proceed. Then focusing on the electrical system, where we focus on the aspects such as service entrance and transformers, where the utility power enters the building and step down to the usable voltage. And then distribution board, where we have multiple MSB, that is your main switchboards, as well as DB, which is your distribution boards, which will split into the multiple individual circuits and its relevant forms. And then containment is where you hold your wires as well as cable trays, ladders, and conduits, pipings, etc. And luminaires as well as devices are basically where you focus on the placement of the multiple model components such as lighting fixtures, power outlets, and switches. And then coming to the plumbing system, as just explained, here we'll focus on both the aspects of substructure plumbing system as well as a superstructure plumbing system. So coming to this, the network of PVC pipes which deliver the potable or the drinking water for the sinks, showers, and kitchens. And then coming to the sanitary waste, here we focus on the large diameter PVC or the cast iron pipes that use the gravity as their main mode of water transfer. And then vent system, where you focus on the vertical pipes that extend the roof to equalize air pressure in the drainage system. And then fixtures which face the parts such as toilets, faucets, water heaters, sink, and etc. So these are some of the fixtures which you focus on the placement in the plumbing system. So now how do you rate this, or how do you have an approach? Is basically all of these multiple parts or the multiple components in detail whatever we have discussed are assigned with a metadata. So now metadata is a particular kind of data which you are integrating to each and every kind of component, where it is not just a physical appearance, but in addition to the physical appearance, it will also have its material, flow rate, system type, and etc., which will eventually help in calculating the kind of pump which is strong enough to push water to the upper floors or the electrical circuit whenever if it is overloaded, and then etc. So the key part here we have to understand is each and every part or fixture or any kind of device which you are installing into the building model should be assigned with the metadata, which is the core crux in your MEP stage. Now let's see what are the different features we focus in the service management using the BIM aspect. So here we have the multiple features where the features are divided into 3 phases. So the first one is design and clash detection. Second one is prefabrication and logistics. And the third one is facility management, which will be our topic of interest for today. So let's see individually what these 3 aspects or 3 phases which are focused in the service management using the BIM concept or the BIM tools. So firstly, let's briefly understand what is a clash. So now people working in the BIM domain will be very well aware of that. Basically, clash is a particular kind of collision or an interference happening between two or more elements, where you try to reflect and see the discrepancies in the model. Now, for example, it can be such as an mechanical, electrical, and structural model are overlaid one upon the other, and after overlaying one upon the other component, you try to identify that one component is getting injected or collided, or even it is having a duplicacy in its placement. So, such as a duct running through a steel beam, so which can be potentially a clash, or a pipe intersecting with the column, etc., which can be potentially identified as a clash. So now the task with the BIM environment stakeholders is that you try to identify and resolve these conflicts or your clashes, right? So there is a particular workflow to be incorporated. So let's see what this particular workflow is all about. So here I have just zoomed in the workflow to be done. So firstly, what you try to do is you integrate the model, that is the multidisciplinary model. For example, you have an architecture model, later your structural model, after that your MEP model. You integrate all together and make that as a coherent model or a multidisciplinary model. So once you try to integrate and finally receive a federated model or a coherent model, you detect the clashes using the n number of tools. So one of the famous tools may be, for example, Bexel Manager or maybe Navisworks. Like this, a tool can be used to detect the clash. So once you detect the clash, then you identify the clashes. So the identification of clashes is the process where you try to observe what is the magnitude happening, as well as what is the placement of the particular clash happening beyond the structure, and all that you will identify. And then you will report the clash, that is, you will generate the clash report, and then proceed further for the resolution. So the resolution of the clash should be done back again to the authoring tool itself. That is, wherever you have developed the model, maybe Revit or maybe Tekla Structures, wherever you have developed the model, your design authoring tool. So there you should resolve the clash and try to see what are the different iterations possible with the multiple clash free or the clash detected clashes where you're trying to rectify it, resolve it, right? So you do that, and then the final feasible iteration will be again integrated and made sure that that is a clash free model. So that is about the design and clash detection which can be performed in this particular task. So here going a little bit further ahead, let's see what are the different types of clashes in the BIM environment. So the first one we have is a hard clash, where you can see that in the picture at the right side, which helps to check the clashes between an individual group of elements, where it detects the clashes where the elements go through each other or not. You can identify that from the first type, that is the hard clash. The second clash we have is the hard conservative, where you help to check if there are elements within each other after having a hard clash, whether you will later check again if there are some more elements happening in that. That is hard conservative. And then you have the clearance clash, where you see that potentially there might not be a clash happening, but still it is entering the buffer zone, which might not be feasible to execute it in a practical way. For example, maybe you can think that there needs to be some buffer or some kind of minimum spacing which should be given for a column as well as window, which is an architectural component. You cannot place both the components very side by side, right? So that kind of scenario, you can refer it to a clearance clash. Then the next type of clash we have is a duplicate clash. So where you can see that the clash here we have is a particular sort of one model getting completely overlapped with the another model. So that is said to be a duplicate clash. And then the other type of clash we have is the containment clash, where we have, you can see that there are multiple elements or more elements within the defined or the constrained room or a space, rather than the one or the more other container elements. So these are the different types of clashes which you can eventually look forward as well as try to detect when working with the aspect of MEP model. So we will have a slight demo after we finish the entire presentation for today. So we will run a particular kind of clash test for an MEP model and check how the clashes can be detected. Now, the next phase in this service management using the BIM environment is the second phase after the first one, that is the clash design and clash detection. The second phase we have is prefabrication and logistics. So let's see what is the potential of this. So here where you have the model accuracy in millimeters, the contractors can pre-manufacture all the service modules offsite itself. So either the efficiency can be focused on the entire rack system, such as pipes, cable trays, and ducts, which are built in a factory and then dropped into the building. And you can focus on the waste reduction, which can eventually be a hazard at the construction site. So the exact material counts which means the less scrap metal can be taken to the site and then assembled and used at the construction process. And then the next one, we have the third phase, that is the facility management. So coming to the facility management here, so basically the facility management is entirely about the post construction. What is the core crux of your asset or the particular facility you have created in the particular building? So either it can be a swimming pool, or either it can be an elevator, or either it can be HVAC duct, or either it can be a sprinkler system, right? So what is the entire type of maintenance you are trying to focus on this particular asset is what we will focus on the facility management aspect, where the BIM model itself becomes a digital manual for the entire life of the building. So where you try to track the asset with the model be dependent on the manufacture date, warranty info, as well as maintenance history. And then the IoT integration can be done into this stage, where the latest BIM applications are used to establish a very good interface between the real-time model as well as the virtual model. So here you can see a slight kind of workflow on the right side of the presentation, where the 3D model you have, and you can try to interpret the asset data as well as maintenance schedule and the IoT sensor, which are integrated from the real-time construction. And then you can use it in the virtual dashboards, maybe for example, and tools such as Power BI can be used to eventually reflect on your facility management aspect. So that is about the facility management, which are the three key phases in your service management using BIM. So one particular example which I have tried to present it here is about streamlining the MEP design for a metro project. So here you can see that how each and every metro station or the client will focus on a particular metro station for the entire track alignment, as well as the relevant aspects with respect to HVAC pipes, as well as utility pipes and etc. in the underground as well as the superstructure. So this is about a typical representation when you focus on the MEP design for a metro project. So which can be potentially a very good approach, right? So let's see what are the different tools which are helpful in this particular domain. So the first one is Autodesk Revit, which is a very prominent tool that is that will be helpful in the authoring purpose of design and analysis. And then for the purpose of clash detection and coordination, you can focus on Autodesk Navisworks. And the other one we have is MagicAD, which will help in the mechanical design solution, and also Dynamo, which is a latest plugin or a kind of additional process where you can use it for the computational design purpose, where you can eventually speed up the entire modeling aspect or your design aspect. And then we have the other collaboration platform, that is ACC, known to be Autodesk Construction Cloud. So this is about the tools for BIM in the MEP stage, right? So that brings down to the first stage of my discussion with respect to BIM for service management. So if possible, I can take a couple of questions at this stage if there are any. If not, then I will proceed.
Participants, if anyone is having any queries, you can either post your questions in the chat box or you can directly unmute yourself, please. Sir, I guess there are no questions as of now.
All
If
right,
there are
fine.
any, we will take them at the end of presentation.
Definitely, yeah, I would be happy to answer those in the later stages of our today's training session. Right. So moving ahead, let's see what is the next topic we have. So the next topic we have for our discussion is BIM for infrastructure management. Right. So now BIM for infrastructure, or IBIM, which is also a very famous acronym, which is pronounced or termed in the BIM environment, is more or less associated with multiple infrastructure kind of works. So the multiple infrastructure works can be confined towards roads, bridges, tunnels, railways, as well as water networks, metro works, and so on. So you try to focus and manage this entire infrastructure with the aspect of scaling it from millimeters to kilometers, where you define it in a very millimeter and then scale it to a large range or a vast range, either maybe an entire city or maybe an entire town in the aspect of smart city planning as well. So when you are taking this in a large scale aspect, now here comes the very important aspect of integrating it with GIS. Why? Because at the end of the day, your infrastructure is assigned or is focused for the aspect of execution at one or more locations, right? So here comes the aspect of GIS, where we say that as geographic information system, and how you entirely manage this integration is our next topic. So let's have some brief couple of basic understanding with respect to GIS, right? So let's see what it is all about. So basically, GIS is a technology or a platform that captures, stores, manages, as well as analyzes and visualizes the spatial data, which is your three coordinate system data, which will include your map, satellite imagery, as well as the other geospatial information. So here you try to integrate and analyze the different data from the multiple sources, right? So we have multiple sources here, maybe a Bhuvan portal, or maybe a number of paid platforms or unpaid platforms, also free portals, where you get the data from the sources and then help in understanding that from the patterns, relationships, as well as trends in the geographic data. Maybe it can be a rainfall data, or maybe a population data, or either it can be any kind of water data or any particular kind of disease data. It is unlimited, or the range is large, right? So that is with respect to geographic information system. So what does it address? Basically is it can address with respect to a location or a quantity or the measurement, whatever you have focused on, and it eventually helps in understanding the patterns as well as trends, and also it helps in reflecting the surrounding conditions, relationships, as well as the topographical establishments, and also implications or the predictive analysis which you are planning for the future, right? So eventually you can just have an understanding something like this, which you are trying to focus about how the topography is there in this particular location, that is the representation of your sea as well as your rock as well as your green cover. So that is some understanding with respect to this particular map. Now let's see how the context is there with respect to BIM and GIS integration. So firstly, here the understanding is that unlike a building with a fixed footprint, the infrastructure lives within the landscape. Now, as informed, it needs the entire overlay or the understanding of a topography or the landscape, how the infrastructure will look really when after the construction happens. So the BIM models are overlaid onto the GIS data, where your topography, soil types, existing utility lines, that is your underground utility lines, will be enabled to understand the environmental impact. So now here, to make use of your realistic conditions to be reflected as a GIS data. So one of the prominent or the kind of the latest tools we use is drone or a lidar, which helps in creating a 3D map of the existing terrain. So something like this, a cloud point can be generated using any of the UAV, that is your unmanned aerial vehicle, right? So which will eventually help in understanding what is the true or the real condition of the particular geography. And then you can also try to simulate your hydrological modeling, so where you can simulate a new highway which will affect your water drainage and etc. So that is with respect to site context and GIS integration. So let's see what is this next phase of linear coordination. So the linear coordination is again the comparison between your utility pipelines with its installation as well as without its installation in the underground. So where you're managing your linear assets such as your railways, pipelines, which definitely need a specific geographic as well as a specialized coordination in the particular location. So where you're focusing on the alignment planning, such as optimizing the path of a road to minimize earthworks, cutting of the fillways or backfilling of the valleys and etc. And also the utility conflicts, finding where a new bridge foundation might hit or have an overlap with the ancient sewer. So utility conflict is again something which is the topic a while ago we have discussed, that is a clash where eventually you can try to focus and understand whether these utilities in the underground are having any clash or a conflict, or if not the interference with one or more elements, or it is having a very seamless kind of arrangement in the substructure. So that is about the aspect of utility conflict. So let's see what the workflow, how this can be done, right? So of this aspect, BIM basically focuses on the high level of detailing. So as I'm sure that when you are focusing on the aspect of BIM in an architectural parameter, so you might be exposed to a topics known as LOD, which is level of development, where we focus it as from the conceptual design LOD 100 till the last one, that is LOD 500, known as built model. So where you are entirely focusing on the each and every minute detailing with the aspect of BIM in the geometric modeling aspect. Then in context or in the aspect of GIS, it focuses especially on the building position concerning to the environmental context as well as the global coordinate system with respect to the project where you are planning to establish on. So when you're trying to integrate this both the concepts, so it will eventually help you in fetching you the high detail building data with the real world geographic context. So definitely with the advantage of both these platforms, finally you will get a very seamless realistic world representation. So this integration helps a more coordinated approach to manage the complexities, risk and interdependencies in a large scale as well as the mega construction projects. So we will be discussing that ahead with a couple of case studies also. So let's see how this GIS as well as BIM integration workflow in a small figure representation, where you are preparing your entire BIM data, maybe for example in any design authoring tool for example as Revit, and then you geo-reference the BIM model, and later you connect this with ACC, that is your Autodesk Construction Cloud, with one of the platforms known as ArcGIS GeoBIM, and then you overlay the BIM model on the GIS context, and then you run your integrated analysis for your overall target of your understanding the pattern or behavior and etc. So this is a kind of very generic kind of workflow. So where the tools used or the potential usage of tools can be with respect to Autodesk Revit, ACC, that is Autodesk Construction Cloud, as well as ArcGIS GeoBIM, right? So let's see some couple of case studies with which it can be applied on. So the case studies can be focused into the aspect of highway construction, where the GIS tool can be used in the route alignment as well as land use analysis, whereas BIM can be used in the bridge as well as the pavement modeling. And then the outcomes are focused on the optimized alignment as well as the reduced rework. So this can be one scenario where you can apply it for the highway construction. So let's see the second scenario, where you have a smart city project where GIS can be used in the aspect of utilities zoning, as well as that is the basically the land zoning and etc., and also population data representation, whereas your BIM can be used in the enhancement and development of your buildings as well as representation of MEP models. So the outcome of this integration will eventually help in the improved urban coordination. So the another scenario here you can focus on, maybe for example is a solar power plant project where GIS can be potentially used in evaluating as well as assessing the solar potential as well as site selection. So it can be a geothermal site, or either it can be a solar thermal site, or either it can be a hydel power project. So it can be relevant to the area of which you are selecting it, and also focusing on the BIM aspect where you are trying to establish structural as well as the electrical layouts, and then the outcome can be delivered in the aspect of efficient energy planning. So let's see some couple of case studies. So the first case study we have here is the construction progress with field issue entry and management with the help of GIS and BIM integration, which is performed in Ohio State University campus at USA. So let's see what this challenges are basically in this particular project. So the challenges here are confined to the aspect of limited infrastructure facilities as well as lack of collaboration between the stakeholders. So the solution through the BIM GIS integration was enabled in such a way that ArcGIS tool was used in the asset management for the data collection, management, analysis, planning, design and construction, and the relevant features. Then Revit was used to compile and connect the digital construction of an accurate 3D building model, which had been done by assembling the multiple 2D drawings which are used in the construction and documentation. So eventually the results focused in this particular case was in the aspect of enhanced support for the facility management, as well as maintenance and safety, and also access to data for relevant decision makers, as well as the smart energy consumption monitoring, which was done throughout the project from its project life cycle. So that is with respect to the first case study. So let's see the second case study. Here we have, that is the design coordination tracking for collaboration of a HS2 railway line, which is in London, Birmingham, UK. So let's see what is the basic challenge with respect to this project or this particular case. So the challenges faced in this particular case are lack of collaboration among the multidisciplinary teams. That is here, since it is a railway project, you will eventually understand that you have the structural team working together, you have the GS engineers working together, and also your MEP engineers working together in the railway line alignment and etc. And then preservation of environment, as well as a large underground construction which was involved for this entire stretch of this particular railway project. So let's see the solutions, how they have approached. So the autonomous drones, which are equipped with high resolution cameras, were used in the help of, or if not the capturing of the survey data, where they have uh, acquired the accurate 3D digital topographical map. And then ArcGIS Enterprise allowed this integration of 3D GIS data into the aspect of SIM, that is your city information model with high quality 3D BIM data. So the integration eventually helped in establishing all the stakeholders to visualize and collaborate on common platforms, right? So eventually they automated the manual data entry process in the aspect of design of rail, tunnels, bridges, and earthworks. So the focused results are in the aspect of 30% project duration was saved in the planning stage itself, as well as the accelerated design process, which saved the 20% of time in the design stage, and also approximately 3 million pounds was saved in the cost of in the pre-construction phase of this particular project. So this is about the aspect of the application with respect to BIM and GIS integration in the aspect of infrastructure management. So let's see some tools in this particular regard. What are the different tools we have? So tools in this particular integration we have are Autodesk Civil 3D as well as InfraWorks in this BIM GIS integration, which focuses on the aspect of roads, drainage, and site grading. And then we have the very famous tool from Bentley, that is Open Roads as well as Open Bridge, which focuses on high popular large scale rail as well as the bridge infrastructure parameter. And then we have Autodesk InfraWorks, as well as the next one we have is Forma add-in for the Autodesk Revit to import your GIS data, as well as the ArcGIS GeoBIM platform, which is an integration for this entire simulation of this particular BIM GIS integration. So let's see some couple of advantages in this particular domain. So firstly, here the advantages we have in this integration domain for the construction sector are, it helps in accurately visualizing your BIM-based models into the particular referred geo databases. And then it helps in analyzing the BIM data, where you can have the geospatial context, whether it can be an urban planning project, or either it can be infrastructure management, smart city planning, and etc., or if not the spatial analysis. And also it eventually helps in the real world context of any particular building model, which allows in the informed decision making for the multiple stakeholders and the relevant planning stages. And also it helps in the asset management process as well. Application of this structured workflow will ensure the data integrity as well as interoperability among the BIM and GIS system. So where you will not have any data restriction or any kind of closed BIM environment, where everything seems to be evaluated as well as executed in an open BIM environment, where you can use multiple platforms and you are not having any data restriction, and eventually it is encouraging the scope of interoperability in a BIM environment through open BIM context. So let's see this conclusion in the aspect of both the stages, that is your the first topic of BIM for services management, as well as BIM for the infrastructure management. So firstly, as we know that BIM is not just about any one particular software or any one particular tool. Basically, it is an entire construction management process which is applied throughout a project lifecycle as a strategy, where the designers can eliminate the physical conflicts before the execution, and the contractors can build faster and safer using their prefabrication works. And also the BIM and GIS integration, which was our second topic with respect to the infrastructure management, is changing the construction and infrastructure industries. So this combination of BIM and GIS with the spatial context is enabling the multiple stakeholders, or if not the project teams, with an opportunity to make the projects more sustainable as well as smarter with the cost-effective projects. And also this application of BIM and GIS is very vast. You can see the case studies as well, where you can apply it to the multiple aspects such as urban planning, solar power projects, highway construction, disaster management, and etc. So that is with respect to the aspect of our case when we are discussing on this topic given to me, that is BIM for infrastructure as well as the services management. So if you have any queries, I'm open to take it now. Otherwise, we'll just switch over to the demo part of the usage of the tools. Yeah, now I open the platform for queries.
Very good evening, sir.
Yes, please.
Very good evening, sir. Till now, presentation was very good, sir.
Yes.
The BIM application is used for treatment plant, wastewater treatment plants or sewage treatment plants. It is possible, sir. Any dam structure designs?
Yes, we can definitely use the BIM and GIS integration for the wastewater treatment plants as well. So where you eventually know that wastewater treatment, you have the multiple stages of treatment which is undergone. Am I right? Okay. So where you can entirely fetch the digital twin of the entire aspect of your wastewater treatment plant also, and then make sure that any changes or modification you want to apply it to the real-time construction, you make sure that you are employing your digital twin in a very seamless manner firsthand, and then make sure that the changes replicable or that to the real-time construction as well. Yes, that is very much possible in the domain of BIM as well as GIS integration.
It is suited for dam structures also, sir.
Yes, we have multiple case studies for the dam structures as well. Where if I can recall, so one of the dams in China was also, I have read a paper which was the usage of BIM concept itself.
Sir, what are the applications
thank you, sir.
of?
Yeah, all right. Sorry, come again.
Yeah, what are the applications of BIM that we can use for using the drone surveying, sir? So BIM plus drone, is there any work that is going on by anyone?
Yes, yeah, definitely I would like to share on this aspect. So firstly, when I was discussing the case also, basically the first thing what you do is you use any drone, or if not the unmanned aerial vehicle, whatever you have in your resource as your resource, you use that tool for the capturing of the real-time data. Fine. So the capturing of the real-time data happens through the fetching model of point cloud data. So if you look here in this figure, let me go back to that particular slide. Yeah, so this one, if I'm not wrong. Okay. Okay, fine. Yeah. So, yeah. So, fine. So, when you are capturing the data, right, using your drone or any of the particular tools, there are multiple formats to fetch this figure. Okay. So, the one format we have got this is in the point of cloud, is with the help of point cloud data. And even you can get the entire data in the PDF image also as lines and other commands, right? So now you can use that particular data now to fetch the entire structure in a 3D way, right? So now to fetch that entire format in the 3D way, now there are multiple tools. So one tool which I would suggest from my end is Autodesk Recap. Fine. I would like to just run it for your understanding. Okay. So what you can do using this is, so basically you will get something like this, at the initial stage. So where you can see that here, everything is in the form of a point cloud data. Can you see this?
Yes, sir. Yes.
Right. So when you're using this point cloud data here, right, now you will take this in the aspect of format known as RCP, and you will integrate that into the Revit tool itself. Okay. So now after importing this entire point cloud data, or if not your PDF image into your this thing, your Revit tool, you can start modeling each and every parameter of this entire data which is captured. Maybe for example, you want to create this kind of stool itself, which is not right away possible with point cloud data. I cannot use it as a parametric component. Am I right?
Yes,
Okay.
sir.
Now you will use this point cloud data, import it to Revit, and then make it a, I mean, the entire structure of how you have captured the data. So that can be done right away from Revit itself. So one particular topic which you can refer to this is the aspect of heritage BIM. Okay. So now if you see the multiple case studies, maybe for example, the aspect of your Roman or Italian structures and all. So most of the renovation projects happen through this concept of HBIM only. I would try to display that here in the chat box. HBIM is heritage building, heritage BIM.
Okay, sir.
Heritage BIM. Okay, which is HBIM. Or if not, some people also tell that as historic BIM. So all your heritage structures are being renovated or being reconstructed using this particular concept itself, right? So that is one of the main useful applications using your drones, or if not any laser scanners, lidar scanners, and etc. Yeah, not just drones, also your lidars also. Yeah.
Sir, in continuation to this, what will be the infrastructure that would be required for doing this work? Like for the building that you have shown just now using the Autodesk recap.
Yes.
So, what could be the infrastructure that one can use for
Firstly, to
getting all
capture
that
the data,
information?
you need a lidar scanner, or if not a drone. Okay.
Okay.
And after that, you need to convert the point cloud to one format known as RCP. Okay. So that will eventually happen only through the device which you have captured. So it is basically uploaded to the server of that particular device from where you have collected. So it will have one small memory card. Okay. So then you can convert it using multiple online platforms. Right. So all this workflow processes will require based upon the scale of work which you want to perform, right? Now, for example, maybe you want to capture a large data of one maybe for 2 kilometers. Then the precision of your equipment will be need to be in a very precise equipment you have to purchase, right? And also there are multiple consultancies also which will eventually do this work and fetch you the data at their own capped price and all. Okay. So that will be the first task, to capture the data using your lidar scanners or drones. Yeah.
Okay, sir.
Yeah.
I guess there are no queries so far. Maybe we can go with the demo and then we will take up the questions again.
All right, fine.
Sir,
So yes, sir,
sorry,
please.
Raghavendra sir.
Yes, please.
So the data capture may be superficial data. I mean, data visible on the ground.
No, it's not anything superficial, sir. It will fetch you the exact data in a very precise manner. It is not anything superficial. Whatever is visible to the naked eye, you will get the surface captured in the format of point cloud.
Is there any means of capturing data where
It will
this?
not penetrate. Definitely, I get your question. It will not penetrate and capture
Yeah.
the data beyond the any opaque object. For example,
Okay.
I have a water bottle like this, and I am
Okay.
placing my pen behind this water bottle.
Okay.
Okay, and you are trying to capture from the front. It will
Yeah.
capture only this water bottle, but it will not capture this
Okay.
pen, because that particular device will not penetrate. I mean, the laser lidar scanner will not penetrate inside this and fetch you the detailing of your pen. So what you do is you reposition your lidar scanner in multiple areas and then
Mm.
take a all around capture of your both water bottle as well as your pen, something like that.
360 degrees.
Yeah, exactly.
Okay. Thank you. Thank you. And one more, of course, I don't know whether it is relevant or not, and just out of curiosity, I would like to ask.
Please, sir.
This leaching of this industrial waste into the ground sometimes happen in the
Yes.
vicinity of some industries and all.
Yes.
Then, is there any means of knowing that happening inside the ground level to capture that so that
Sir,
we can
maybe.
advise our dwellers?
Yes,
Or,
that is a very good research question to be thought about. But here, maybe not just restricting our technology to BIM, but whereas we have the aspect of multiple geophysical exploration techniques, right? So maybe that
yeah,
we can try to incorporate and try to understand the behavior of the penetration level of your leaching effect.
yeah.
Yeah.
Might be.
So
Okay.
that can
Thank
be
you.
considered. Yes.
Yeah, sir, I guess we can proceed with the
All
demo.
right, fine. Okay. So firstly, I will proceed with the aspect of class detection process. Okay. So which I have explained that in the topic of BIM for service management. Okay. So class detection, as I informed, is basically the place or the particular process where you eventually try to observe what are the collisions happening in the particular integrated model, which is comprising your structural, architectural, as well as MEP details. Okay. So one of those very renowned platforms we have are two here. I am showing that on the screen. One tool we have is Bexel Manager, and which is from the Bexel service provider. And the other very well adopted tool we have is Naviswork Manage. So it is basically from the Autodesk service provider. So we will just see one sample demo using the Navisworks Manage about how to run the class test, right? So let's see that. So basically, this is the user interface after you open. Okay, so Autodesk Naviswork. I hope people are aware about how to create an Autodesk account and then install the Autodesk products, maybe with the valid license for 1 year. Are the people aware of it?
There is a mixed response about it, sir. Some of them are aware and some of them are not.
Right. Okay. Definitely. Maybe people from the academic background are
They know about it.
might be aware of it. Fine. So definitely,
Yes.
as per, yeah, I do get that. So the people in the academic background, so definitely can create an Autodesk account using their institutional mail ID, create an account, and then download as well as log in with their student, I mean that institutional mail ID, and then use the Autodesk products for the valid license of 1 year. Yeah. So that remains same for the usage of this tool also. So let me load one project first. Okay. Fine. So here I have tried to load one project here, right? So in the tool that is your Autodesk Naviswork. So here, when I have tried to select, you would have observed that I have selected three files. So I'll just re-show that. Okay. So here you can see that it is a structural file, MEP file, as well as the architectural file. Okay. So this is the um, composition of that particular file where I have integrated and made it as a federated model to run the class test. So to just to cross verify that, let's see the section view of it. Okay. So let's see that part. So here now you can see that what the building or how the building is made up of. So this is the model which we have integrated now. Right. So here you can see that basically you might think that everything is very proper and it does not have any issue. So that might be the general perceivance or the general understanding which everyone will think that all the building components are placed in a very proper manner, right? So this is how you can perform any section for the loaded model and then see what are the different uh, components comprising in it. So just to show this selection tree, so here you can see that. So these are the different levels created for the model. So that is architecture model you have, MEP model also you have, as well as the structural model. And in each model, what are the different components? So here we can see that. So even in the basement as well, we have the building components. So yeah, so this is the basement portion, right? So here also we have the footing and the relevant components, right? So that is how we can check it using the section option, right? So now let's see how to run the class test. Now, firstly, here in the home page, so you'll have one option known as class detection, class detective. So you should enable that option. So after enabling it, the next thing is you should just expand this tab and just observe it here that okay. So now here you will see that there is two selections, one is selection A and the other one is selection B. So let me tell you what this selection A and selection B is. So generally the purpose or the understanding we perform in a class test is we try to identify that are there any collisions or any clashes happening among the elements of architecture one as a set, or on the other side we have MEP on the other set as the components. So you can take that as one discipline against the another discipline or one component against the other components. Always it has to be something like A versus B. So on selection on selection A, you will take one set, and on the selection B, you will take the another set. But firstly here we have to add one test. Now, for example, I have clicked on add test and then I will name the test. For example, let me make it as clash test 1. So that is the name I have given. Okay. So after giving the name, so now here you can see that it is a new class test. And after that, you can see that since before I did not create any class test, all these selection sets were disabled. Now, as soon as I create a class test, you can see that I can select the multiple selection components, right, from selection A and selection B. So you can click on this plus symbol and you can see the expansion of each and every discipline. Now what we shall do is we'll run a test between the architectural components against the MEP components. Okay, so that's why I have selected here the selection A, that is architectural, and in the selection B, that is the MEP. So if you drop down this here, there is one more option, that is standard type of selection. Next is the compact selection, and the other one is property selection. Now, standard selection is where you will have each and every discipline right away getting selected. Okay, you can see that in each and every discipline, there are multiple levels, as well as in multiple levels, there are multiple components as well. Okay, so that is how the standard selection will work like. Now, when I just change it to compact, now you can see that you will not see the different components in each level. Are you able to see the different components in each level? Can you see the difference? Can anyone respond? Yes, participants, any response? Is there a difference or is it same?
Only floors are seen, but what are the components in a particular floor are unable to
Unable to
visualize,
be
no?
viewed. Yes,
Yeah.
exactly. So that is the power of creating or taking this option of compact, where the entire discipline will be considered as one unit and it will run the test. So that is the difference between compact as well as standard. So it depends upon the usability or the requirement of the client about what is the type of the class test he or she is uh, expecting. So let's keep it standard only. Let's not change that. So as informed, I'm taking selection A as architecture and selection B as MEP. So after creating the test and selecting these particular options, let's scroll down a little bit. Now here, if you see this, we have studied about multiple class types, right? So those class types can be viewed here, that is hard clash, hard conservative, clearance, and duplicates. So one more class type, can anyone of you tell what is not available here? We have referred to 5 types. Only 4 are available here. What is the other type of clash? Any response? Okay, no problem. So the other type of clash we have is containment clash. So which is a basic kind of limitation you have in Navisworks tool, whereas that type of clash is available in the other tool, which I have shown you before, that is Bexel Manager. So you can select the type of the clash here. For example, I'm keeping it as hard clash only. After that, we can set the tolerance limit. So the tolerance limit is something like a permissible limit, where you're setting some limit. Beyond that, beneath that, the particular kind of clashes will not be identified. So I am setting the particular tolerance limit, and then you want to link it with timeliner. Of course, timeliner we did not discuss here, so that's why I am not emphasizing much on that. So basically, timeliner is nothing but your simulation kind of aspect which you can perform in the Navisworks tool, right? So these are the main kind of settings which you should um, I mean, set it before running a test. So after fixing these particular options, then you can run the test. So now I have run the test. You can see that totally. Let's go to the dashboard and observe what are the total number of clashes. Fine. So for the set values as well as the given references, the total clashes we have got are 770 clashes. So which means completely there are 770 clashes in this building model. So you can see here, whenever you tap on the relevant clash, it will redirect you to the particular view. For example, I'm selecting clash number 22. So here there is a clash. So that's why it is highlighted in red. So you can see that here. So you can press on the relevant clash and observe what is the clash happened in the model. So here also you can observe for the clash 28. So to understand that, what you can do is you can just scroll to the right and observe that what is the magnitude of the clash as well as what type of clash it has occurred, and all those details you can see that. So and also on the right side there is one more option known as display settings, where you can see that what type of viewpoint you have set and the relevant details. Now the next task which is relied in the particular aspect of this particular project is that these clashes should be resolved, for which you should take this project again back to the model where you have authored it. That is, maybe for example, Revit, you have modeled or authored this particular kind of building. Then you should take back to that particular, you should take this model back to that particular tool and then assign this entire report to the particular modeler and make sure that all these clashes are resolved in the tool. So like this, you can generate a report of this. For example, I'm taking this option to the report, and then you can see that each and every field, whatever I want that in the report, I can select it. And after that, I can select the report format, and then selecting it, I can click on this one. So let me change some settings because I have some restrictions here. Maybe right now I'm not able to save it, but definitely you people can save this in the format of any report in this particular format type. So that is with respect to the clash test. Is it clear?
Sir,
Yes, sir,
uh,
please.
in the, I mean, where the in the window where we have seen, four types of clashes
Yes,
where
sir.
containment was not there, you said, no? So
Yes,
in
sir.
that window, in the same say space, right side bottom, some step, yeah, into this one.
Ah,
What is that step?
this step, this is the total second for running the test, sir.
Okay.
Yes.
Something like in ANSYS, we give stepwise
Ah,
computation. Is that
close to something like that only, sir. But
okay?
it does not have much prominence, sir. Either you can
Okay.
see here, you cannot add any field also.
Okay.
Does not have much impact on the model and running the test set. Not an issue.
One more from maybe
Yes.
student side. I
Yeah.
mean, just out of curiosity, I'm asking. In
Yes.
software side, I mean, when these coding engineers does their work and pass their say job done, it goes to finally quality QA cell, no division, quality assurance
Mm.
division.
Yes.
So similar to quality assurance in software sector, will there be exclusive engineers in this domain who can identify clashes and solve the clashes exclusively for that purpose or something like
Yes,
that?
sir. The BIM modelers will do those kind of tasks in this domain.
Okay.
BIM modelers' role is to resolve the clashes as well.
Right.
Hope I have answered you.
Yeah.
Yes, sir. Yeah. Okay. So moving ahead with the next tool, let's see the usage with respect to that. Are there any queries or should I proceed?
Yeah, yes, we can proceed, sir.
Okay, right. So since there are no queries, I will proceed. I will close this. So the next tool here we have is Revit. Okay. So let me open that for the purpose of MEP modeling, right? So, okay, please wait for a couple of minutes. Right. So here you can observe that I have tried to represent one of the student projects performed here at our campus, right? So basically you can see that the model, which is in a very, how to say this, which is not in a dark stage, right? It is dim. Okay, so that is basically the architectural model. So using that architectural model, we have tried to create the HVAC, or if not the entire MEP we have done for this model, I mean for this particular project work. So where you can see that here, how the different connections have been performed, right? For example, all these are your HVAC ducts, and these are the air terminals and its relevant flex ducts, right? So that is for the HVAC part. And then here you can see that there are some fixtures, that is your sink, where you can see that the pipe running ahead is basically the aspect of your overhead tank pipe connection. And here the line which is going beneath, which is in green color, so that is basically the one for the drainage pipe, right? So which will go to the substructure work. Okay, so that is how you can do that. And one more thing here, you can see that how the walls and the other aspects have been created. Now, those who are very much familiar of Revit, I don't think so I have to explain the user interface, but When you work in the aspect of MEP, the first thing to be noted here is always your MEP works should be worked on the ceiling plans. For example, HVAC ducts as well as your electrical works. Whenever you are trying to do, you create the particular discipline as well as the floor plan or whatever the floor plan first. When you have that, you will use that as a reference, and the modeling will be done in the aspect of your ceiling plans only. So that's why here you can see that I have opened a ceiling plan, right? So where you can see that how the ducts have been placed. So this is the second floor ceiling plan for the mechanical aspect. So here you can see the different disciplines on the right. For electrical, you have floor plans as well as ceiling plans. So whenever you want to work on electrical components, you take its relevant ceiling plan. And then for mechanical also, you have the relevant aspect of creating the HVAC template. So for the HVAC template, you will use the ceiling plan. And then plumbing also, you will use its relevant floor plan. So definitely for plumbing, you might not require your ceiling plan unless and until you have a overhead tank to be placed. Otherwise, you can proceed with your floor plans, right? So now I am opening this. So here you can see that the ceiling plan. Yeah. So 1 minute. Yeah. So this is the ceiling plan which I have opened. So let's see one particular component about how to create that, of course, with the limited time what we have. Now, for example, here you see that these are the connections we have for the first floors, second floor ceiling. So here you can see that the air terminals place as well as the HVAC ducts and its flex ducts place. So let me open that. So this is the particular view of that. So these are those particular connections or the modeling paths. So let's see how to place that. So for that purpose, let me delete the existing ones. Right. So now you can see that that particular air terminal as well as the flex duct has been removed. Right. So earlier here there was one. So now we have removed that. So now let's see how to place it. Now, whenever you are starting your MEP components, so the first thing you should do is on Revit, you should switch over to the tab that is systems. Okay. So once you move to the systems, so then you will find all MEP relevant kind of components. So firstly, the component which is here in blue color, right? So that is known to be the air terminal. So we should select that air terminal. And going to the properties browser, here you can see that there are different types of air terminals. One is the extract drill, after that return diffuser, supply diffuser and all. So the colors, so the representation which is blue is said to be the supply diffuser. Next, the return diffuser is your pinkish color thing, and the extract diffuser will come in the green color. So here you have this extract, right? So that will come in the green color. So now let's place a supply diffuser, for example. So I am going to this particular tab, selecting the supply diffuser. And after selecting the supply diffuser, the first thing you should observe here is on the left side, what are the constraints? So always it should be on the ceiling. So level 1 is that the elevation from the particular level is 10 feet above the particular ground level. So that's why I'm taking this particular thing and I am placing it. After placing this particular air terminal, now the next thing is I should connect this with the flex duct. So I am taking the flex duct and then I'm taking the option for it and then connecting it. Like this, we can connect it. Now let's see that in the 3D view. So now it should be moved further to represent the flex duct shape, right? So now you can see that here we have placed that flex duct to the air terminal. So like this, you can create it, right? So yeah, so like this, you can create it for the multiple components. So now, for example, here as said, on the left side here, you will find the mechanical components and your mechanical equipment and the mechanical control device. So if you move to the right, here you have the electrical components, wire, cable, conduits, and etc. And on the left to that electrical, you have the plumbing components like pipe accessories, plumbing fixtures, sprinkler systems, and so on. So that is how this particular project has been done with respect to the aspect of MEP components. So that is this one. So any queries with respect to this? Can I proceed? All right. So if there are no questions, I will proceed to the last tool, that is MicroStation. So here you can see that. So this is basically with respect to the discussion which we had as a last topic for us, that is BIM and GS for the infrastructure management integration. So that we have discussed, right? So one of the tools we have is MicroStation 2025. So which is a Bentley supported tool. So let's see how that can be done. So this is something like where we have a framed structure placed here, right? So where you can see that that kind of structure, I hope whoever is in the domain of BIM can very simply create this particular framed structure, right? So here, this is a very well-known tool in the domain of BIM, which has been used from so many years. Maybe if I'm not wrong, it was started in the year 1984. And in the latest times, what they have got is one aspect of integrating your Google Maps. I Here I would like to explain that why we are giving the Google Maps option is to make us visualize that how you will have the representation of this particular frame structure or the particular building, any particular building also in the real time. Okay. So after that, you should do some settings here into the project. If you go here, you'll have the aspect of settings. So now in the options here, maybe for example, if you go to the file settings and all, in the design file settings option, here you will have the options to make sure that how your project location and etc. will be set. And after setting the project location and etc., you'll go to the map type, and then instead of none, you will take the any satellite or hybrid type. Now, for example, let's take the satellite imagery, okay, for which I have selected for my location. So now after selecting that particular satellite imagery, now you can see that how this particular model building will look like in the location which I have set for the project. So that is how you can represent it. So of course, this is not the entire demonstration for BIM and GIS integration, but just an overlay of maps with respect to the modeled structure in the 3D BIM. Why? Because during the explanation also I have said that the tool which we have is RGS GeoBIM platform. So that is really a very helpful tool in the domain of BIM and GIS integration, or if not InfraWorks also. Right now, I couldn't have the access of that. So that's why I couldn't show that in the demonstration here, but definitely if anyone is willing, we can get in touch and then we can work on any project with respect to the same type of interest. Yeah, so that's it with respect to the aspect of discussion for today from my side with respect to the topic given. If there are any queries, I'm ready to answer.
Participants, if you are having any queries, please post your question in the chat box, or else you can you can unmute yourself and you can ask the question yourself.
How many years you have been into this, sir?
Sir, my entire PhD is in BIM domain itself, sir.
Okay.
Yeah,
So
it's basically
when
considered
you completed
by
your PhD?
BTech is civil engineering, of course.
PhD, when you completed, sir?
I have finished in 22, sir.
22. Now afterwards, you're, practicing it.
Yes. After that, I have worked in different organizations. So later, I joined here in ICMA 2 years ago.
You explained very nicely, sir.
Yeah,
I
thank you, sir.
appreciate it. Thank you. Thank you.
Sir, regarding the GIS integration,
Yes,
So
sir.
you have shown about the ArcGIS, right? So
ArcGIS, that is
yeah,
not basically the ArcGIS GeoBIM. That is only the usage of Google Map overlaying for any building project you do. That is not
okay,
ArcGIS GeoBIM. Yeah, you
okay,
can do that in ArcGIS GeoBIM. You can take the model, integrate it to ArcGIS GeoBIM. There is one platform. So provided you have the license, you can do that
okay.
with the overlayer layer stuff and all. Yeah.
And how much time, uh, how much time will it take for the clash detection to complete, sir, for a regular G plus 5, let us say we are looking at a G plus 5 or G plus 6 residential or an
Class
institutional
detection,
building?
running the class detection test will not take much time, sir. Even if you have seen that when I have run the test, it hardly takes maybe 10 to 20 seconds. That's it.
Okay,
Class detection, running the test is quite faster. Uh,
Solving takes time.
yeah, resolving will take a lot of time. Exactly.
Resolution is going to take time.
Yes,
Okay.
sir. Exactly. Any other queries from the participants?
Jagadish sir, if there are
Yes,
no queries, then I think you please proceed.
yes, sir. Yes. Sir, we have a question on you mentioned about the hydraulic modeling. Um,
Yes, sir.
so, can you throw some light on that part, on how that can be done or how that can be applied in real time?
Sir, basically, hydraulic modeling, hydrological modeling, as you know, that it is basically helpful in the flood analysis and all, right? So,
Okay,
any particular kind of society or maybe a kind of particular zone, if you select, right? Now, it depends on the topography for the flood analysis, right? Now, you might have the different heights or the different shapes of the structures, right? So now when you are trying to integrate your BIM model into the GIS platform, now your building model is basically added as a layer, and then you are running your flood analysis as per the geographic location, whatever you are trying to conduct it, right? So why
okay,
we basically do this is to make sure that it will help you in understanding what is the type of the footing as well as what is the minimum spacing you should provide between the buildings so that it will not have a water logging in that particular area when you have the buildings. That will be the kind of one of the applications. There are various, so I just said the one of the applications in this particular.
okay.
Yeah.
Thank you, sir.
Yes.
Participants, if there are any questions, we will take. Yeah, I guess there are no other queries that we can expect. Sir, with your permission, shall we go for the vote of thanks, please?
Yes, sir. Definitely. Okay, from my side.
Uh, Now I invite our final year student, Ms. Dhruti, to please propose vote of thanks for today's session.
Good evening, everyone. I'm Ms. Dhruti. I'm honored to propose a vote of thanks for Dr. Raghavendra Kumar's insightful lecture on service management in BIM. Dr. Raghavendra has taken us through a comprehensive journey of BIM, starting with definition, concepts, dimensions, and parts of BIM. He then explored the domain of MEP, explaining components, color coding, and clash detection techniques. His detailed explanation of clash types and resolution strategies was particularly enlightening. He further broadened our understanding by introducing us to the service and facility management branch of BIM, highlighting advanced techniques like IoT integration, assessment, asset tracking, and point cloud scanning. The example of streamlining MEP in metro projects showcased practical applications including hydraulic modeling and GIS integration for infrastructure management with ample case studies for best understanding. Dr. Raghavendra also shed light on alignment planning of infrastructure, utility conflict visualization, and clash detection, emphasizing the importance of resolving these issues in project execution. He comprehensively explained BIM implementation in infrastructure management, including long-term asset resilience aspects. We sincerely thank Dr. Raghavendra for sharing his expertise and providing valuable insights into the world of BIM integration into service management. Thank you.
Thank you, Dhruti. Now, sir, with your permission, I would like to request all the participants to please turn on your videos for a group photo, please. Please turn on your video for a while, and upon intimation, you can turn off your video again.
Yeah, so I would convey my regards to the entire organizing team as well as the management of CVR College of Engineering, Hyderabad, for giving me this wonderful opportunity to share my experiences as well as knowledge in my capacity. Yeah, thank you for giving me the opportunity and looking forward for multiple other assignments whenever given a chance. Thank you. Yeah.
Definitely, sir, definitely. And as you have seen, our Professor Murli, sir, is the one who has asked you many questions today.
Okay.
He's been very supportive to us and a guiding wheel for this STTP from the beginning.
Right. Okay. Fine. Good. Glad to know
So
that.
a special thanks goes to our head of the department, Professor Nagamaleshwara sir, and our Professor Murli sir for their continuous effort for making this. And they are the ones actually who encouraged us for the past 1 month on making us, conducting on this topic was their
Main agenda.
it is their vision that we made it to happen.
Yes. Glad to know that. Yeah.
Thank you, sir. Thank you, participants. Sir, with your permission, can I close the session now?
Yes, sir. Definitely. Yeah.
Yeah.
Thank you,
Thank you.
everyone. Have a nice evening. Thank you all. Bye. Take care.
For the participants' information, the feedback link for today's session is posted in the chat box. Please do fill your feedback. I'm once again posting it for your reference, please. Yeah, those who have completed, they can leave. Thank you, everyone. Thank you. Have a great evening.